Since the smoke came out of the NV-M1 video camera, I've been having a look in the service manual to see what's going on. I found this component here, which is an array of transistors, is where the smoke came from, and the pin that was getting the hottest and showed burning of the solder on its pin was this pin here, pin 13, which is the power supply for the capstan motor. And measuring on that pin to ground showed around 5 ohms, which compared to the same pin of this chip on the M3 camera, that's not right. The M3 measured much higher resistance. The circuits here are fairly similar between the two cameras, so that was lucky I've got something to check from. So I have now desoldered this chip. The pin doesn't measure low resistance anymore, so I'm not sure what the problem was, because I was expecting that low resistance would remain after the chip was removed, and then I'd be able to fault find what is causing that low resistance. Like some components shorted out, the motor driver maybe had a problem, but so far I was not able to find anything. Here is the chip that I pulled out, the transistor array. You can see it's been quite burnt, so that's where the smoke was escaping from. It doesn't appear to have damaged anything else in the vicinity. It was soldered in along there. It's quite a fine pitch. Let's take a look in there. You can see where it came from, and you can see its slight blackening on around the pin that was getting super hot. There is a resistor there nearby, but I don't think that has any issue, and there's also a bit of wire there, but that's untouched. We could measure the resistor just to make sure it still is a resistor. 1.2k, that seems pretty sensible, doesn't it? Anyway, what we're going to do is what I have done. I got the equivalent board from an M3 camera, and I desoldered its transistor array, which is hopefully in good condition. I know this board does have a fault, and the fault is that it doesn't turn on at all, and it's because I unplugged the viewfinder. Either that or I plugged it in while it was powered up, and it didn't seem to like that. The camera just shut off and would not turn on again. I don't know what that burnt out. I haven't investigated it at all because I had another board available from another unit that had a different fault, so I just swapped the whole board to get that other camera working. So I've harvested this chip from it, and we'll solder it in here, and then we'll carefully power it up and see what happens. Along with the investigation, I just thinking I must have shorted something out. The only thing I could find is this yellow wire here, which is in the cable that goes to the capstan motor. That got squashed between the circuit board and the little post that the board screws down onto, but it wasn't squashed enough to break through the insulation, and it still has continuity, so I don't think that is the problem. And I wasn't able to find any other similar issues around, so who knows what the problem was. Is it possible there was a screw sitting somewhere that shorted onto something? What I think we'll do is, once we get this new IC in, we'll try powering it up on a current limited power supply, and that way hopefully we can avoid any more damage to it. Let's put in this new chip and see what happens. It's a SIL package IC, and it's got a flat there to indicate pin 1, which is down that corner there, and then that's pin 16. Quite a lot of pins. You see on the original one what they've done is cut a bunch of the pins short there, and then this is a little fuse which was leaning down over it. I had to lift that up to get the solder sucker in there. The holes are very tight fit. Yeah, the pad of the pin that was burning is lifted up, but I know where that one goes. As I measured it, it's somewhere over here, because I was confirming what was going on. Check that it's definitely around the right way. Solder that in place, and then we'll power this thing up carefully and see what happens. Some exciting soldering. We'll have to re-lean down that fuse if we put back if this works and we put the whole thing back together. Yeah, that's the dodgy pad, so I've got to be careful with that one. There is a surface mount resistor in there, which its solder got sucked away when I was desoldering. And I've got the hugest soldering iron tip I can find on here, so that's good. That's good because we can do two at once. Without bridging, because it's got solder mask and it's got silkscreen between the pads, so that does quite a good job at preventing bridging. Enough that we could solder two pins at once, which is quite nice. I think we're ready to power it up. What I want to do first, before we power this up, is power up a M3 with 12 volt power supply connected onto the battery terminal, just so we can see how much current it would normally draw, and then we can set up the power supply before we test it on the M1. If we limit it to just 2 amps, we'll see what happens. I don't think it's going to draw that much, is it? Let's turn that on and see what happens. And push power. Okay, so it briefly went to 1 amp, and now it's sitting down at 0.3, and the viewfinder's lighting up. Injector's functioning. What we could also do is measure that pin very carefully without hopefully shorting it out, just to see what the voltage is. I think the service manual said it would be around 5.3-ish volts, maybe 5.3. Just put in a tape and try playing it just to see. Oh, we're supposed to be looking at the current draw, aren't we? There you go, it goes to about 600-700 milliamps. It's playing now. Okay, so perhaps we'll set the current limit to 1.5 amps and just check that that can continue to function. Still quite a bit of power though, isn't it? If it was going to burn itself out, it's still got plenty of opportunity to do so. Okay, to have established that we can power it up from this power supply with a sensible current limit, the battery power input connector over here, wonky. Now what I want to do is touch this when we power it up just to see what happens. I don't have thermal camera here right now. Okay. Doesn't seem to be getting warm. Put a tape in it and see if it works. NTSC tape for this one. And it's playing, so we fixed it. I don't know why it broke. It's really confusing. They're replacing that transistor array, brought it back to life, but why did it break in the first place? Who knows? But let's be brave now and try it with the AC adapter, because that's what it was running from when it stopped working. Carefully connect this off and see what happens. I'll just touch this to see. Fine. I think we can even get a view of that. There you go. So it's playing back fine. But we should connect the camera section back up to it and check that that functions without overloading anything. I'll power it off and we'll just connect that. Might as well get rid of that, so we don't need that at the moment. And we'll connect up the camera. I've got to the servicing aid, the extension cable, so that you can remotely mount the camera. Although this isn't all of the signals, because I also think that they've constructed this wrong. Have a look at this. It's been made by a cable that's 1 to 8 or whatever the number of pins it has. So it's not a 1-to-1 cable, because there's a shielded wire there from that side which ends up at the other side, and then they've just glued a header into it, into one of the connectors, but they've glued it into the wrong one, because when you connect this into the camera like that, the shielded cable in the camera doesn't connect onto the shielded cable here. So it should have had the header glued into this side, and then the shielded cable would have matched up and gone through. So that's weird, isn't it? A defective thing. I found this on eBay. I looked up the part number that was in the service manual. Found this on eBay. It was new, unopened in the packet. So I wonder if they're all made like that. Short run thing. It doesn't really matter. Guess, who knows? But I think in order to do any recording, we have to connect up this other cable from here. This 3-pin cable here, which goes to the hand grip part, which has got the record button on it. Otherwise you can't trigger the recording, because I'm not sure. Well, let's try it anyway. Let's see if this works. I'm going to touch that again while I power it up, just in case it burns. That seems to be okay. Look at that, the camera has come up. That's exciting. This has a different macro. There's a button to press in to enable the macro, whereas on the M3 cameras, the button's in the zoom lever. Let's see, if we put the recording on. Right, you have to push the button on here to start the recording. Most interesting thing to record, isn't it? The corner of a screen and the bottom edge of another screen. And there's the service manual on the screen. Oh, we haven't set the white balance though. You've got to get this special lens cap thing, put that over it, press that. And there you go, now we've set the white balance. Awesome. Let's stop this, rewind it back. There you go, look at that, it's playing back the recording we made. Perfect. Nice clean picture. Yeah, it won't play after it because this isn't an NTSC tape. It's just a random scrap tape for testing machines, and we've severely creased it up on some of the previous machines that it's been in. Very good. So that means, does that mean we can now put this thing back together properly, as we were trying to do the other day? It was the other day. Try it, I guess, see if we can put it back together and not have it catch fire again. What a bizarre thing. Because we were at the point where it was time to put the final covers on, the side panels, and thought, oh, we'll just test it first, and it didn't work. The problem is now all the screws are put away, far away. Is it possible it didn't like being turned on without the viewfinder attached? So would that burn it out? It shouldn't. Did I ever test it without the viewfinder? Yeah, all the wires are so nicely laid into these. It's quite an artwork, an art form. Oh, it's the plastic piece, isn't there, that goes around there. That's what I pulled out when I was arranging it. This special thing goes in there. And that's what should hold all the wires back so that they don't accidentally short out by being squished like that. Keep it all nice. Oh, don't squash that under there. That's for the camera connection. We've got 3 little screws here. Ah, we have to lay down the fuse now, otherwise it's going to stick out too far. Sure that we're not squashing any wires. It could just be that ground being made messed it up. Oh, that doesn't make sense though. Why would that happen? Should we test it again now, or put the camera apart? Is it possible that something on here touched something down here? Shouldn't be, because everything is tied out of the way properly as we expect, and it's all insulated as it should be. Try and get that plug lined up properly. What happened to the 3-pin plug? Oh, we lost it somewhere under here. Oh no, it is there. Okay, well that stuff's in position now. I think we can attach the camera in. Screws in loose to start with. Make sure that there's no stress on the corners of the board there. Seems to be okay. Now the top 2 screws of the board. Guess we're actually doing a smoke test for real, aren't we? The actual meaning of doing a smoke test. Making sure that the smoke is going to stay in. So let's do a smoke test now to check that all the smoke is going to stay in. We need to work out how to route this wire from the viewfinder. Did it come up down there before? Get that pulled into the right place. And also the microphone wire. Okay, well let's give this a smoke test now and check if the smoke stays in. Hope it stays in. After all that, otherwise we're just wrecking another board, aren't we? Oh, that goes to the remote pause thing. So you probably use that to trigger the camera instead of this when testing it. I've got a remote pause thing somewhere. Should we go back to the power supply? I'm just scared now that it's going to just catch fire again. I don't want to wreck this after all this work we've done to it. Okay, let's turn that on. And seems to be okay, it's come up in the viewfinder there. Does that mean we've won this time? Maybe. So what are we going to do now? Put the rest of the housing back together. Does anyone remember what the order is for doing that? Let's start with this stuff over here. Was that hidden screw? Now that can go on. I don't think there's anything else we have to do in this area. We got the red screws in. Cables are fairly well under control now. Make sure the microphone cable is in the right place. And the viewfinder cable. We have to remove the eject control. There we go. Something is not right in this corner here. It hasn't clicked in somewhere. It seems to be okay. It's just perhaps the way the cables are bunching up under there. See, these older ones, M1 and M3, the design of them is really good. They've packed in as much as they can without any excess space inside it. Everything just fits in perfectly. Same can't be said about the newer models, M5 onwards. They're quite a mess. Internally, have wasted space. Oh, that needed a short screw, did it? So there's a silver colored screw for going on the side here so that the styling is kept good. Oh, what was up with that? I don't remember there being a super short screw. Well, there isn't one. And that's countersunk too, so it has to be... Was there something else in there? Don't know. Okay, we'll try to put the other side on. Oh, that was the eject thingy. Ah, yes, there is a short screw, look. Here we go. So that one is a shorter countersunk screw and it's a little like, passivated whatever gold thing. So we're going to refit the power standby switches to this panel. There's this weird little assembly with metal bits and pieces, which I don't think I needed to remove, although it is a red screw, but the little board clips into that. It's a weird little thing. Okay, that's connected. I suppose I could have just undone the wire, but I thought it was going to be too short and be really awkward. Anyway, get that out of the way. There we go, so that will hold that part together. Then we got the microphone. The microphone needed to go on first, because that slides into there. Can we get that on now? Oh, that's a bit annoying, isn't it? Let's try and get that in there. There we go. Lucky we can get it in there now here, because that then goes over it. everything lined up and the screws go together nicely. There, which had the ground wire on it. Oh, it's a countersunk one. I was just thinking because you don't want a countersunk one to hold that ring terminal, but yeah, it's because the countersink's in the plastic part. It's also a bit dodgy because you shouldn't really be attaching electrical connections with a mounting that also does other things like mechanical mounting. It's not really good practice. Well, it is not good practice at all. Grounding needs to have its own bolts, fixings, not shared with other things. Although that's in the electrical systems. Now what's going on here? I think because we took all the viewfinder apart, the wires are bunched out more than they were before. I think the problem is I've routed the viewfinder cable in the wrong place. I think it's supposed to come out up here, not down there, because that there is now in the way. Oh, that's a shame. We've got to pull all this stuff off. Just slide that out a bit. Wonder how little stuff we can get away with. Take that off again. And that off. I suppose we could just be following the instructions in the service manual, couldn't we? Because that would tell us exactly what things we need to do, in what order and where to put them. Will that fit on now? Yes, it fits on now. Okay. Yeah, now that I've seen inside the M5 camera, this is a lot better designed. A lot less haphazard. Now this top panel mounts on. This goes back into place. And then there's this cold shoe kind of thing. And then it's got 3 really long countersunk screws under it. Or on it. And then there's the cover plate for that. And it's got one little tiny weird screw on it. It's got a little weird square head. Okay, so I think we're done in that area. Now at the back, and we've got this which slides in. Remember, it slid off pretty easily. And then there's 4 screws on that. And I'm a little bit concerned how many screws we've got left after all this though. Where else do they go? 2 on the bottom. I think we forgot a screw somewhere inside. There's a thing that looks like a screw hole, but I don't think it is. Yeah, I think I messed up somewhere and forgotten a screw. Let's check under here. Put in the one that goes under there. Oh well, I think it's just too bad. Maybe there was another one somewhere in this camera section. There's something loose here. Not like this is ever going to get used again either. It's just for fun to investigate old things. Okay, so on the bottom there's 2 more screws to do. So we've got 1 left over. It didn't come out of a different camera. Unless there was one under the microphone, I don't think so. Yeah, it's a little bit disappointing, isn't it? To get to the end and there's 1 screw left. Were there any under this that I was supposed to do? Maybe that was it. No, I did that one. Put back this door. And then we'll do a final check to see if the smoke escapes. It'd be pretty sad if it does now, after all that, after we'd proven that it was working again. There's little bungs. Okay, awesome camera. Let's see if it works. Comes up. plays. Great. It's Macross Plus, I think, from Laserdisc, recorded onto a tape. It's not particularly exciting, is it? There's not much going on. Just some kind of discussion. Viewfinder's lit up. Yep. Picture on the viewfinder. Slightly out of sync with the camera. So I don't think that this transistor array is just going to fail by itself. Something must have been shorting out when I powered it up. That's the only thing that would make sense, but whatever that was, I don't know, and it seems to have stopped doing that now. So there you go. There's the National NV-M1 video camera. Well, perhaps we'll take a look through the service manual as well, because that's got a few interesting bits in it. Got the original analog service manual here for the NV-M3. Also covers the line adapter, this thing here. Let's take a look in this, see what the deal is. We already discussed this in the previous video, that it's a composite to S video converter. So it separates the luminance from the chrominance of the input signal. It feeds that into the camera recording. It's pretty simple, not shielded wire. Little bracket that holds that connector there. Oh, the service manual is too disruptive. So it's got a little filtery thing in it for doing that. I don't know if there's any ICs on this. See if there's anything on the other side. No, single-sided components. So that's it. So it's just a little filtery thing. You could probably look at the schematic in the service manual. So the cable here, what we'll do, that will be the luminance, chrominance output there, which are the two cores, and then this other stuff which carries on will be the video and audio output that comes out of there, plus the power connected through. I think that will be the audio input, just linked through. Yeah, it's just hard linked through. Got a bit sticky from that tape. Good. This is a Panasonic branded one. It just sits there, does it? Okay. Here are the details for the line adapter. It says in a very convoluted way there that you can connect the video output from a TV or the video from output from another device to the video here and record it on the camera. To get your M3, plug this in and it switches from camera recording to line input recording. And that's it. So you can use this as a regular kind of VCR thing without a tuner though. So here's a layout of the circuit board. Pretty simple, not very much going on. Interesting, there's a switch there. A micro switch circuit board. Let's take a look at the schematic. When you plug something in, plug the adapter into the connector there, it switches the power source for the camera from the battery to the adapter input. So that means you can't connect that little video output adapter thing there and run the camera off battery. It has to be powered by this adapter input when it's connected. So the There's 12 volts gets regulated down to 8.1, and then that gets used by these circuits after going through some filters. The signal path is from the video input connector, splits, capacitor coupled, transistor buffer, and then there's a band pass filter here centered around 4.43 megahertz. That's the color. And then there's a low pass filter here, 3 dB point of 4 megahertz. So that's for the luminance, the Y plus sync. So it's just two filters and some buffers, and that's it. Simple device. You can see there the pinout of the adapter connector, all the things that it supports there. 12 volts, battery 12 volts. So that battery 12 volts actually gets fed into this device to be switched, which is interesting. Must mean that there's another switch in the camera that does the same thing. So yeah, 12 volts going to the camera, battery coming out of the camera, ground, auxiliary, which gets grounded by connecting the adapter. So that must be how it switches. So it's not done by a switch that gets pressed by a certain shape of this plug. It's actually by this pin 4 being pulled low. That's interesting. So there's the audio in. Charge will be the battery charge signal. Does that mean you can charge batteries in these cameras while they're on these cameras? I wasn't aware of that. I'm not sure. There's a heater there. I think that has some 20-ish volts, which keeps the tape head and the mechanism slightly warm to stop condensation forming on it. Y plus sync in, ground, chrominance in, video out, audio out, audio ground, video ground. So those outputs to get the signals out of the camera. So that's the line adapter. Interesting device. So this has seen better days. Seems to be well used. There must be a lot of these cameras around, and it's end of life now. Not sure when they wrote that on there. So let's have a look. Here they show the service aids, the Jigs, servicing Jigs, and they've got the 9-pin camera extension cable, which is the one that I have, the only Jig that I have. And as we identified before, I'm pretty sure this has been manufactured wrong, that this socket was, well, this header was supposed to be inserted on this one, because the shielded cable there seemed to not line up with the shielded cable in the camera section, and that is supported by this picture here, because if we line that up, the second pin there is, the second connection there is a dark colored one, whereas that end, the second connection is a light colored one. So it suggests that it should be that way, which is what you would see if that was the socket and rather than the header. That is the light one, that red wire, and the dark one there is the shield of the shielded cable. So yeah, well, it works anyway. That's interesting. That's how you connect up the camera. There's a ribbon extension for the M3 so that you can fold this board out, extend the ribbon, take that off, the control panel gets taken off and brought down so you don't have to disconnect it, and then this ribbon goes there up to the mechanism. We didn't see that in the M1 because it didn't use that flex. So this thing here, YC separator, used for taking the place of the camera so you can put a signal in, is probably exactly the same as this. So that they should just, well, if you've got one of these, you could probably connect that onto a header and power a video input. They don't give any detail of what's in there though. I've not seen one available. Anyway, that's the M3 service manual. We'll take a closer look at that shortly, but first let's have a look through the M1 service manual because it's got some interesting things. I've only got the digital form, not the analog like the other one. This is the PAL version. That's just what I could find online. But even though I've got the NTSC M1 camera, they show the remote. We forgot to look at that in the previous video when we went through the accessories. So I've got one right here. This is a Panasonic one. Cord, and it's a 2.5mm stereo jack on there. But I've got a mint in box, probably never used one, Look at that. Original box. It's a bit squashed. So this is the national one. Made in Japan. Pause remote control unit. So let's get this out and have a look at it. Look at that, it comes in a long bag. That never unwrapped the cord. This came with one of the cameras, I don't remember which one. But there you go. So in this one they call it record pause, whereas this one is just got record pause symbols. Maybe this one goes to parts of the world where they speak different languages. So you only need to have this one and it suits all the areas because you can understand the symbols. It's the E version. I think it's got French on it. This is the EN version. National, is that what the N stands for? Anyway, this one's mint in box or in packet, so we'll keep that one good. It'll never ever be used, I guess. It'll just stay mint in the box forever. It's sad really, isn't it? Shame the box is squashed. It's just in one of the pockets of the camera case. We're going to take this one apart and have a look inside it. Don't expect we're going to see much though. It's just going to be... We could look in the service manual, couldn't we? To see what's in here. It's an LED and a switch. There you go. And they even tell you on the board which one is the red wire, the white wire, and a ground. So it looks like it's using a shielded cable. That's it. And the cord grip is just rolling the cord around the screw post. It's pretty easy. Should have used this before instead of having to hook up the hand grip thing of the camera to make it easier. It goes in there. So I guess the reason why it needs 3 wires is because the LED is separate to the bottom. That's pretty easy, isn't it? And the current limiting for the LED must be in the camera because there wasn't any resistor in there, which is also a good idea because it means if this cable gets damaged and it gets shorted out, it's not going to burn out whatever drives the LED in the camera. Fairly high leverage for such a tiny connector there. Good, that's the remote pause. M1 service manual. By implementing a large number of the latest technological developments from a wide range of diverse fields, Panasonic succeeded in making this new VHS movie NV-M1 a standard in terms of low weight, compact dimensions and overall operation. The service manual contains these technical information which will allow a service technician to understand and service the Panasonic VHS movie NV-M1 AC adapter pause remote controller. The new NV-M1 features a new high sensitivity Nuvicon pickup tube that allows making the image in even in 10 lux illumination, half-inch viewfinder, playback capability, 6x power zoom, f1.4 lens with macro, a new 4 rotary heads helical. That's not quite right, is it? From translating to Japanese, it should have an L in there. Japanese doesn't have an L, so they use an R. Helical scanning system that achieves complete VHS interchangeability. Yeah, which was quite an advantage over the original beta cameras of similar form factor, which could only record. There was no playback ability because of the weird way they implemented it. Oh, look, we're looking at the same thing. I think they just copied some of this stuff. Well, because it just stayed the same between the cameras. Head amp. So let's start off with some summary instructions, which we can skip over. And then they go into what are the differences? A simplified total block diagram for this model. So it's got the camera part, the viewfinder, then the VTR section, luminance, chrominance, motors and head, audio circuit. So this is interesting here. There's a comparison chart. Through many new innovational technologies, what? Oh, though the through? I don't know, what are they talking about there? Though the many new innovational technologies have been developed to attain such a remarkable compact size, the rest of the circuits mechanism are not changed from conventional VHS because of its interchangeability. Then what are the differences? First of all, they're described in the following comparison chart between the NV-M1 and conventional VHS. So it's interesting here. What is conventional VHS? Well, it looks like what they're talking about is one of these. A National NV-180. Pretty sure that's what they've got here. And to go with it, they've got an NV-A2. They haven't got an A1 because the A1 doesn't have this part here, the autofocus. And in their picture there, they show it with autofocus, which is quite interesting because they're comparing this stuff here to the M1 video camera, which does not have autofocus. They probably should have put a picture of an A1. They're trying to say that the M1 is a better system where it actually has less features than this conventional VHS. You get this cord 10-pin camera plug, which is pretty standard. Connects onto here. Put the battery in there, or an AC adapter can slide in there, or you can connect a tuner unit up to here so it can function as a conventional home VCR. And then there's a shoulder strap that connects into here so you can carry this around and then use this lightweight camera. The VCR controls are mirrored up here so you can remote control it. You put the VCR into remote mode and then you can control it by these, and of course the record here starts and stops the recording. So they got rid of all that and they combined the VCR into the camera, and they reckon that's better. So they say here the cylinder diameter conventionally 62 millimeters, now in the new system 41 millimeters, and it used to go at 1500 rpm, now 2250 rpm, and the wrap, which was 180 degrees, is now 270-ish. And what they're doing is right here to make that work with the normal VHS tapes, whereas previously each head recorded each alternate line or track on the tape. Now the 4 heads go in turn, so each head records every 4th track, and through doing that you get a smaller head and then you get a more compact mechanism. So they describe that there. L1 head there does the first track, then R2 does the next, then L2, and then presumably R1. And to make that work, they've got to do head switching, because while you're recording with, say, this one, the other ones are in contact with the tape, so they can't be writing or reading at that point. So there's a circuit here which has this waveform applied to it, which switches the heads on and off in playback and recording mode, in record mode there, so it gates the signal going to the head, and in playback mode it looks like it just shorts the head out so you don't receive any information from the one that's not active. And the arrangement of the mechanism there with the various guides and rollers, which saves a bit of space. It's not that much really. So you look at those drawings that are probably to scale. It's interesting. So what is the color camera? It's one of the most complex pieces of electronic equipment on the consumer market. This stuff. They go through how the camera works, how the tube works. The electron gun forms a beam of electrons that is focused to get a point as small as possible at the place where the beam strikes the target. The electron beam scans across the target, which is coated with a photoconductive material. The circuit is equivalent. The photoconductive layer creates a number of individual elements. These elements construct electrostatic capacitors in parallel with light-dependent resistors. Target elements are all connected on the end of the signal electrode, the target, and the other end is unterminated, ready to receive the beam. So when the electron beam strikes that, then the light that's falling on that light dependent resistor is reflected by a current flowing out of the target connector. So there's no light striking the face. The light dependent resistors that create a high resistance. Whenever light hits the face of the target area, the resistance drops. The level of drop depends on the amount of intensity of the light. And then they go into how does that get turned into color. It's because there's stripes of colored filters across the surface of the tube, and as those get scanned you get alternative colored or filtered representations of the light in the scene, and then that gets processed to create the color difference signals RYL and BYL that can get turned into a composite signal by taking the luminance, and then the mixed color differences create the composite signal. So they go through how to disassemble it, how to clean the head, how to adjust everything. It was mainly that small head business that I wanted to discuss there, because I think I incorrectly mentioned it in the previous video. Now if we look at the similar section for the M3 camera, similarly it's got some instruction manual, some instructions at the beginning, how to do all of the things, depth of field, all the good stuff. Then we go to what are the differences. So it compares, perhaps we should look at the digital version of this. Would that be easier? I'll be able to zoom in a bit better. In addition to the technical merits of the conventional VHS movie, the M1, this model, the M3, highlights other superlatives. Okay, which means they have added autofocus, auto white tracking or white balance, and it has facilities for recording external signals via the line adapter, the thing that we looked at before. That wasn't in the M1. Consequently, some circuits are developed and improved versions of their conventional equivalents. So they've improved some things over the M1. This section describes the differences. So the dew sensors were moved. I guess they weren't detecting well enough, precisely enough. So there's now two of them, one up by the cassette mechanism, which is in there, and the other one underneath near the head. Camera on-off control. I think that means that now when the AC adapter is connected, the auto power off after 5 minutes is disabled, which is good, because when you have it running on AC you might want to have it powered all the time. There's a backup circuit which will continue to retain the character information, I see, of the counter, I guess, because there's no titling on this. The camera and line input switching circuit, so that's new, so that's done with a little analog switch. The servo signal circuit, new ICs, even these above new ICs are used. The circuit of inside based on M1 and our ICs are the same as M1. Okay, so there's a few differences there. In the servo, the video circuit stays as the same, although they've moved it around a bit, because it's now on, I think it's on a different board. The camera circuit, in addition to the M1's camera circuit, the autofocus and automatic white tracking are employed, so only those circuits are different. So that's it. So there's the little sensor thing that we were looking at, which is that thing that got fully corroded. That's what they've got there. The reference voltage, a blue filter and a red filter. A low illumination cut. Control voltage generator. Okay, so the levels of light falling on those two filtered light sensors. I guess those are photodiodes. Controls through this a gain to the two signals that come out of the camera. That's cunning. So that there's taking average amount of blue light in the scene and red light, and then controlling the gain. Now the autofocus system, based on triangulation method for measuring the distance between the object of the camera by projecting an infrared beam and receiving it after being reflected by the object. Position sensitive device is used as an infrared receiver. Really? A position sensitive device. Okay, not sure what that is. When infrared ray hits the position sensitive device, it would generate a current which varies inversely with the distance between the infrared hitting portion and the output pole. Okay, so there's an IR LED inside the camera lens, and then that other bit, so that thing there, is the receiver part, the receiving lens. Okay, so there's a prism inside there. Okay, so I think that's what that part there is. I think that's the IR LED that they mention here. Pretty sure that's what that is. That is, yes, it connects onto this board, the autofocusing board. Okay, so that means there's a prism inside there. So this shows how that works. Infrared ray comes out of the lens and then into the sensor part, this thing at the bottom. And then there's the amplifiers, some filters, buffers, and then there's that lens encoder, 6-bit, and there's the autofocus motor so that it knows exactly where it is. So there's a picture of that lens encoder, and there's the codes that come out of it. It's quite a complicated thing, so it's an absolute encoder for the lens position. So that's it, so that's all the differences. So there's a bit of servo stuff and the improvements to the camera. So the other thing was the LEDs inside here. What do they do? Also just noticed that that wire that we cut off from, I think, the shielding of the deflection, that just goes to this capacitor here. It doesn't join onto the tube socket. It's just the other end of that capacitor, which then shares a pin with something. A resistor also. Yeah, this wire is rated at 10 kV. Yeah, so we've got in there a few LEDs, and those are the bias light. That shines a little bit of light into the tube that gets the stuff just on the threshold of conducting or detecting light, so that in low light conditions not as much light needs to fall onto the tube for it to actually pick up something. That's the idea with those little LEDs there. Bias the tube on slightly to get it ready to go. So that reduces the lag because the less light has to fall on there to charge up those little capacitors. I don't know if there's any mention of that in this. I think that's been rambly enough, has it? Here we've got an actual national videotape. They have a nice case here. It's not a cardboard thing, it's actually a plastic thing. So this is a premium standard national videotape. PAL market, E. And here we've got a new, never opened Panasonic standard, the T120. So that will be the same length of tape in there, but since it runs a little bit faster for the NTSC system, so you don't get quite so much runtime. And then we got a Panasonic super high grade E180, which also has never been opened. That's quite exciting. It's got the little thing so it can hang up in the shop. Yeah, shall we open it? I have to wait till a special occasion for that. Well, at least this one's open, we can see it. Good quality videotapes. I've got a brochure about them somewhere. The national videotapes. There's a whole range of different types. Premium standard, the super high grade, I think there's extra something or other, and there's also one designated for hi-fi audio recordings. Very good. So I think next time we'll have a look at, one of the next times we'll have a look in the AC adapter that didn't work and see if we can work out what's going on there. And also another interesting thing coming up, got the NV-M3 here, we looked at. Pretty interesting. But what is this? This is also an NV-M3. NV-M3EN. NV-M3. From Japan though. The Japanese national logo. So this thing is also an M3. It's got the same model number as this, but it's a CCD. It's not tube. So that part there is flat, where it sticks out on that one. So what's up with that? Why have they called it the same model number when it's different? See there how much that sticks out, and there doesn't exist. Also the viewfinder arrangement is different. It's now this sliding type, so it's seen better days, and it's connected with a cable there rather than in this style. Yes, that folds down nice and flat, gets out of the way. This one doesn't really do that. It pulls in some way like that, but then it's sticking out the other side. It's a bit weird. There's some kind of latch thing there that doesn't seem to work. Unless it only clicks in at certain positions. Don't know. Anyway, in a next or sort of next video, we'll take this apart and see what's different about it. I'm assuming the mechanism will be the same as in the other M3, but the camera section will be a bit different. It is a bit chunkier looking down here. You can see that's sort of small. Whereas this one, pretty sure that's longer, but it's got a chunkier thing here. I suppose it's the same controls. Can't read it. But there'll be autofocus and the manual auto push thing, and there'll be the white balance, the iris, but there's something else. There's also another switch here. There's a little tiny hidden one, which it's called zone on off. I've also not powered this up yet, so we'll do that in the next video. Thanks for watching.